Chapter 11. Air around us. Is air present everywhere around us? Yes, the air is present everywhere around us. Air is a mixture of gases that primarily consist of nitrogen, about 78%, oxygen, about 21%, and traces of other gases such as carbon dioxide, argon, and water vapor. It fills the Earth's atmosphere, extending from the surface to several kilometers above the Earth's surface. Air is an essential component of our environment and surrounds us at all times. It fills the space around us, both indoors and outdoors, and is crucial for various life processes. We breathe in air to obtain oxygen, which is necessary for respiration and the survival of most living organisms. Even though the air is invisible, it has mass and exerts pressure on objects. This atmospheric pressure decreases with increasing altitude, which is why there is less air pressure at high altitudes compared to sea level. Air also plays a crucial role in various natural phenomena, such as weather patterns, wind movement, and the Earth's climate. It acts as a medium for the transmission of sound and plays a role in the dispersion of pollutants and the diffusion of odors. Overall, the air is present all around us, permeating our environment and playing a vital role in supporting life on Earth. What is air made up of? Air is primarily composed of a mixture of gases, with the most abundant gases being nitrogen, N2, and oxygen, O2. Here is a breakdown of the composition of air. Water vapor. Water vapor is the gaseous form of water. It is created when liquid water evaporates or when ice sublimates directly into vapor without melting. Water vapor is invisible, and its presence in the air contributes to the humidity of the atmosphere. It plays a significant role in weather patterns, cloud formation, and the Earth's water cycle. Oxygen, O2. Oxygen is the second most abundant gas in the atmosphere, constituting about 21% of the air. It is essential for most living organisms as it is involved in respiration and energy production. Oxygen supports combustion and is necessary for the burning of fuels. Nitrogen, N2. Nitrogen is the most abundant gas in the Earth's atmosphere, making up approximately 78% of the air. It is an odorless and colorless gas that is relatively inert and does not readily react with other substances. Argon, Argon is the third most abundant gas in the atmosphere, comprising approximately 0.93% of the air. It is an inert gas, meaning it does not readily react with other substances. Argon is often used in various applications, such as in light bulbs and as a protective gas in some industrial processes. Carbon dioxide, CO2. Carbon dioxide is a colorless and odorless gas that is naturally present in the Earth's atmosphere. It is produced by various natural processes, such as respiration and volcanic activity. Additionally, human activities, including the burning of fossil fuels and deforestation, have increased in recent years. Carbon dioxide is a greenhouse gas, contributing to the greenhouse effect and climate change. Other gases. The atmosphere also contains trace amounts of other gases, including neon, Ne, helium, He, methane, CH4, krypton, Car, hydrogen, H2, xenon, Z, ozone, O3, and water vapor, H2O. These gases are present in very small concentrations but can have significant impacts on certain atmospheric processes and phenomena. Dust and smoke. Dust consists of tiny particles that are suspended in the air. It can be composed of various materials, including soil, pollen, skin cells, and other particulate matter. Dust particles can be natural or anthropogenic, human-made, and their presence in the air can affect air quality and respiratory health. Smoke is a suspension of small particles and gases resulting from the incomplete combustion of organic matter. It is typically associated with the burning of substances such as wood, coal, or tobacco. Smoke particles can vary in size and composition, and their inhalation can be harmful to human health. It's important to note that the presence of dust and smoke in the air can contribute to air pollution and have adverse effects on air quality and respiratory health. Efforts to reduce pollution and promote clean air are crucial for human and environmental well-being. How does oxygen become available to animals and plants living in water and soil? In water and soil environments, oxygen becomes available to animals and plants through different processes. Here's an explanation of how oxygen is obtained in these habitats. Aquatic environments, water. Dissolved oxygen. In aquatic environments such as rivers, lakes, and oceans, oxygen dissolves into the water through various processes, primarily through diffusion from the atmosphere. Oxygen molecules in the air come into contact with the water's surface and can dissolve into the water, creating dissolved oxygen, DO. Aquatic plants, algae, and phytoplankton produce oxygen through photosynthesis, which contributes to the dissolved oxygen levels in the water. Dissolved oxygen is crucial for the survival of aquatic organisms, as they extract it directly from the water through their respiratory systems. Soil environments. Oxygen in pores. Soil is composed of solid particles, water, and air-filled spaces or pores. These air-filled spaces contain oxygen that becomes available to plants and soil-dwelling organisms. The oxygen in soil is derived from the exchange of gases with the atmosphere through diffusion. Oxygen can move into the soil through small air pockets or through the movement of air between soil particles. Plants and microorganisms in the soil utilize the available oxygen for respiration, enabling their metabolic processes. It's important to note that the availability of oxygen in water and soil can be influenced by various factors, including temperature, organic matter content, water flow, and microbial activity. Poorly oxygenated environments, such as stagnant water or compacted soil, may have lower oxygen levels, which can limit the survival and growth of organisms. How is the oxygen in the atmosphere replaced? The oxygen in the Earth's atmosphere is constantly replenished through various natural processes. Here are the primary ways in which oxygen is replenished in the atmosphere. Photosynthesis. The primary source of oxygen production in the atmosphere is through photosynthesis, a process carried out by plants, algae, and some bacteria. During photosynthesis, these organisms use sunlight, carbon dioxide, CO2, and water, H2O, to produce glucose, a form of sugar, and release oxygen as a byproduct. Oxygen production through photosynthesis occurs mainly in terrestrial plants, phytoplankton in oceans, and other aquatic plants. Oceans and phytoplankton. The oceans play a significant role in oxygen production. Phytoplankton, microscopic marine plants, carry out photosynthesis in large quantities. They generate a significant portion of the Earth's oxygen, estimated to be around 50 to 80%. Phytoplankton produce oxygen as they convert carbon dioxide and sunlight into energy. Atmospheric mixing. The atmosphere is continuously mixed through atmospheric circulation processes, such as wind patterns and weather systems. This mixing helps distribute oxygen evenly throughout the atmosphere, preventing it from becoming concentrated in one region and ensuring its availability worldwide. Ozone formation. Oxygen molecules, O2, in the atmosphere can be broken down and recombined to form ozone, O3, through the action of ultraviolet, UV, radiation from the sun. The ozone layer, located in the stratosphere, absorbs most of the sun's harmful UV radiation. Ozone formation involves the release of oxygen molecules, contributing to the oxygen supply in the atmosphere. It's important to note that the oxygen in the atmosphere is part of a dynamic balance. Oxygen is also continuously consumed through various processes, including respiration, combustion, and decay. The rate of oxygen production and consumption maintains a relatively stable concentration of oxygen in the Earth's atmosphere over long periods. Overall, the continuous cycle of oxygen production through photosynthesis, particularly by plants and marine organisms, ensures the replenishment of oxygen in the atmosphere, supporting life on Earth.